We will use series sum and logest for exponential decay model of a Taylor series expansion. Here we have the function y equals a times exponent bx, also known as y equals a times exponent or e to the power bx. Our value for a is 3 and value for b is negative 3 because it's decaying. So we'll generate our function using this range of x. So that's equal to array formula of a times exponent b times the values of x. This is our data set. We will regress this against itself. So we use logest data y and data x and show the full statistics. So you'll notice our a is 3, matches to our value initially for a. Our b is ln b1. So we have this ln b1, which is also negative 3, matches to our value b. Next, we will show this in the chart. Insert chart. And we'll show the trendline equation in the exponential form. So here's the trendline equation in exponential form. So here we have y equals a times exponent bx. So our value for a is 3 and our value for b is negative 3. Next, we generate the data set for the expansion. Here we have expansion equals a times the quantity 1 plus bx squared over 2 factorial plus bx cubed over 3 factorial until bx to the power n over n factorial. So we begin with the n, which starts from 0, incremented by 1. And we will cover until the whole data set. So we have 20. So that's the values of n. Next, we enter the coefficient, the factorial part of the coefficient, which is our array formula, 1 over factorial of the n values. Now we can generate the expansion, which is array formula, a times series sum b times the x values, where the power starts from 0, incremented by 1, and the coefficients is this range. You will notice our dataset for the expansion is the same as the dataset of the function. We can show that, we can regress that against the function. So we enter logest of this dataset against the function. But we cannot expect this to be perfect. So we have an error for a 0.00001. So it's not perfect. And our value for b, which is ln of b1, it's not perfect, negative 3. So there is still an error. Our standard error values of the coefficients, they're not perfect 0. Our stay x, they're not perfect 0. Next, we can enter this into the chart, our data set. We'll edit the chart, add this trend line, the trend line of the expansion. Now the blue data sets are covered by red because they're the same. And we generate the trend line as label. We use expansion, and you will notice the, the function and the expansion have the same trend line equation, where the equation is y equals 3 times e to the negative 3x. That's for the function. And for the expansion, is also y equals 3 times e to the negative 3x.